All right, let's look at a couple of examples using our kinematic definitions. This first example is meant to illustrate the difference between velocity, and average speed. Speed and velocity are two different things, and we can illustrate it nicely with this example. What we're going to have is a swimming pool, which I'll draw here like this. It's going to be a long, skinny swimming pool so that we can imagine just working in one dimension. We'll call this the x-axis. We're going to have somebody jump into this swimming pool. So here's the person. They're going to dive in at t equals 0. They're going to swim the length of the pool. They'll turn around and swim back and then get out at the same place where they jumped in. Let's imagine that this pool has a length L of 25 meters, and that as the person's swimming, this first leg takes 10 seconds. So it takes them 10 seconds to go from the left end of the pool to the right end. Then they go underwater and they do that thing where they kick off the end here and they start swimming back, and maybe they're a little more tired, so it takes them 15 seconds to do this second leg, so that when they jump back out of the pool, a total of 25 seconds has passed. Right? Okay, so we're going to calculate average velocity and average speed for three different legs of the motion here. We're going to calculate V average and S average, average velocity and average speed. For the trip, I'll call it there, meaning this first leg of the motion. And then we'll do it for the trip back, the second leg of the motion. And then we're going to do it for the round trip, there and back again, like the Hobbit thing, right, for the round trip. All right, before we jump in, no pun intended, and calculate these things, let's write down the definitions. Average velocity is defined as the displacement over the time. This is a vector, so it's going to have two bits of information to it, a magnitude and a direction. Average speed is the total distance that we travel divided by the time. Okay, so every step or every foot that you travel along the way is going to count for average speed. When it comes to average velocity, only the change in position matters. All right, so let's look at the first leg here. I'm just going to move these guys over a little bit so they're more lined up with where I need them. So let's scooch that thing over. All right, for the trip there, the first leg. So we're considering now this leg of the motion. What is the average velocity? Well, it's the displacement divided by the time. The time is easy. It takes 10 seconds to get there. So that's easy. Let's get the displacement. I'm going to call it V average there. Now, what is the displacement? Well, we started here at what we can call x equals 0, and we swam 25 meters. So you might be tempted to say that the displacement is 25 meters. But remember that displacement is a vector. This is the magnitude of that vector. We also need the direction. And I'm going to add the direction by putting an I hat here, which now tells me the person swam 25 meters in the x direction. I need that because this makes it a vector, and velocity is a vector. I'm going to divide that by the 10 seconds that it took. All right, so this is easy to divide. It's 2.5 I hat meters per second. I'll say 2.5 meters per second I had. Magnitude and direction. Okay, now we'll do average speed. On this first leg of the trip, what is the average speed? Well, it's a total distance that the person swam. That's 25 meters divided by the time, 10 seconds. So I get 2.5 meters per second. Here we see the units on velocity and speed. It's length per time, meters per second. Okay, so that's that one. Now let's do the leg back. So we're going to come back this way now. This is now the leg that we're talking about. We're now going to imagine starting here and ending here. So let's erase these. And do it for the trip back. Okay? Now this says average velocity is the displacement divided by the time. So what is the displacement? Well, we started here and we swam 25 meters back this way. But again, be careful. That's the magnitude of the displacement. I need this to be a vector, so I need the direction also. This person was swimming in the minus x direction. So there's the displacement. And this tells me 25 meters in the negative x direction. And I'm going to divide that by the time that it took, 15 seconds. We can reduce this to 5/3, which is 1.67. So minus 1.67 meters per second I had. All right, average speed on the trip back. The distance traveled on the way back divided by the time. The distance is still 25 meters, and the time is 15 seconds. So that's 5/3 meters per second, 1.67 meters per second. Last, we need to do the round trip. So let me erase some of this, and we'll do the round trip. So now we're going to consider there and back as all the motion. Now, average velocity, displacement over time. If the person jumped into the pool here, swam, and then jumped back out of the pool, and standing in the same spot, the displacement is 0. The displacement depends on the endpoints, where you began and where you ended. It doesn't depend on the path. This person didn't go anywhere. Net, so the displacement is 0. They traveled, it's true, but their beginning point and their ending point were the same, so the net effect, which is what displacement takes into account, is 0. So even though we have some distance traveled, the net effect was 0, and when we divide this by the 25 seconds, we'll get 0. So the convention on the 0 vector is not to worry about units or direction, it's just the 0 vector. Okay, so no average velocity. If you ever end up in a place where you have been before, your average velocity between the two times when you were there is 0. On average, you didn't go anywhere. You might have gone to the left for quite a while, but then you came back to the right, and those motions canceled. If you ever get a chance to go back to the hospital where you were born, you can go to the delivery room and spend a moment contemplating your lifetime's average velocity. On average, for your whole lifetime, you haven't gone anywhere. You have traveled a lot, you have seen a lot, you have done a lot of stuff, but if you end up back where you started, your displacement's 0, and you have no average velocity. You will, however, have an average speed. So let's calculate that for this person swimming. Average speed is the total distance traveled divided by total time. The total distance is 25 meters going out, 25 meters going back, and it's 50 meters. Now how much time passed? 10 seconds, 15 seconds, 25 seconds passed. So we get 2. meters per second. Okay, so in this case, the average velocity and average speed give us two totally different numbers. The point here is to help illustrate the fact that velocity and speed are very different things. Average velocity and average speed are very different things. They're calculated in different ways. Sometimes they'll give you related numbers, sometimes they'll give you totally different numbers. When you're asked to calculate them, drag out the definitions from your kinematic dictionary and calculate that thing that is showing up in the definition.